In this video, we're going to have a look at bearings and navigation within the topic of trigonometry. True bearings. Have you heard of that before, I wonder? So a true bearing is a direction when compared to true north. Hopefully you've heard of north before. And it's moving in a clockwise direction. I hope I'm pointing that in the right way on the camera screen for you. It's used to describe the direction of one object or place in relation to another. So it's really helpful. You may or may not have heard of it used in the past with out at sea and ships, or people that do cross-country navigations with different, a sport, going across the land like that. So knowing how to read a compass is very helpful and be able to give directions to people of where you are in relation to them. So having a look at this example with town A and town B, have a look at the bearings that we've got there. So just a bit of background information. True bearings, we use 3 digits. So for that 48 degrees, we would start with a 0 out the front. So the bearing of town B from town A. The way I remember it is where it says from town A. Town A is where you start then. So imagine you're standing at town A and you're facing north, and then you're going around clockwise out, and the diagram has 48 degrees, and then we're going off to town B. So the answer for the bearing of town B from town A is that 48 degrees. Let's think of all the different scenarios we could have. Just a note though on the wording, you may also hear the bearing from town A towards B, and hopefully that is fairly self-explanatory. From town A, that's your starting point, face north, and then point out to the direction that you need to go to get to the next place. What if it was the other way around? Bearing of town A from town B this time. So imagine you're standing at B, you're facing north. How far around do you have to turn in a clockwise direction so that you're now facing town A? And so that's that red circle of the 228 degrees pointing around to that line that now points to town A. Or it might be said the bearing from town B towards A is that 228 degrees. You may or may not notice that the bearings actually differ by 180 degrees. You could have a think about that in terms of if the town was 180 degrees from another town, what that would mean. But anyway, it's just something to note for now. The compass rose, that's its official name. What I've mentioned before is worth writing down in your notes book, or if you're preparing a cheat sheet, a page of summary notes for a task, an assessment, a test. This compass rose is also great to put on. Make sure you put the wording of questions, particularly what I was saying there about from town A. Add that, not just the diagram, put the wording in with it too. So this compass rose has the classic true bearing. So it's got the classic north, south, east and west, and they're at 90 degrees from each other going around clockwise, but also handy to note what is northeast. That's at 45 degrees. If we say due east, it means somebody's moving straight east, which is in a 90 degrees from north. So handy to have those ones, particularly 270 seems to crop up a lot, so these are good ones to remember. Another thing that's really handy when you're doing bearings topics is some knowledge of parallel lines. So if you're a bit foggy on those and need a bit of a refresher, you might need to go back and do some work on them. Here's a video we suggest. It's on YouTube. Maybe the link works here, but if not, type into YouTube one called Properties of Angles Formed by a Transversal. Let's see if this works. Yes, the transversal is that line there that cuts through parallel lines. The angles that we're talking about for parallel lines are things like alternate, which was here, co-interior, these ones here together, corresponding, was sort of this one and this one, and I'm having a blank on the other one. But so if you need a refresher on all of those, do some work and look that up. Moving on now. So do remember that true bearings are from north in a clockwise direction and a 3-digit value. Putting the T for true after those 3 digits, that's optional, because if you've got it in 3 digits, we know that that is the true bearing. So how would we answer this question? The bearing of Q from P. Where do you start? From P, so you start at P. You face north, turn in a clockwise direction until you're facing to where Q is and see what that degree is. So in this case, it's 126. So some of the questions that you'll do to start with, it's already got a picture like that done, and you just have to work out, is it Q from P or P from Q? The second one here, the bearing of Q from P. P is the starting. Now, you might be tricked and go, oh, well, it's 41 degrees. I can see from the diagram there. But you start at P, you face north, and then you go around in a clockwise direction, which means you have to go all the way past 90 degrees east, down to south, back up to west, 270 degrees we've gone now to get in line with the horizontal, and now up 41 degrees more. That's why it's 270 there plus the 41 degrees. So don't be tricked by that one. Face north and turn. Example 5, or question 5. So when Walter drives to his sports club, he finishes 10 kilometers east and 7 kilometers south of where he started. Try and imagine that. Walter started somewhere. He went east. Which direction's that? Then south. Let's draw the diagram. So always put a dot wherever you need to start, and then at least put a vertical line to imply north, so you know which way you're facing. Then you're going east, so then your brain's going, oh, okay, I'm going out to the right there, 10 kilometers, so you draw a line. Now then Walter is essentially sitting here, and he now changes direction. So each time round, put at least north in. Feel free to put the whole compass if you like. And now we're going south. Here's the diagram here, and we're going for 7 kilometers. And we're asked to find Walter's bearing from his starting point. The starting point was over here, and sometimes you might like to put a new dot for where Walter is. You could put a W. So we need to have the line connecting the starting point and where Walter is now, and the bearing. So now, welcome to using right-angled triangles to help us solve these, and we've been doing work in right-angled triangles. You're trying to find an angle, and you've got two sides, the 10 and the 7. What can we use there? We have to use SOHCAHTOA. We need to label our triangle. Here's our right angle over here. Our hypotenuse is here, but there's no information. What opposite this angle here is the side 7, so we'd put O or opposite, and over here is the adjacent side, ADJ. Which ratio use O and A? The TOA, so that's tan. So let's work through how we'd write that out. Write out the formula first. Tan of theta is equal to O over A. Substitute in your values. The opposite side is 7. So where you see opposite there in the fraction, put in a 7 over 10. Solving, which is where we need to do inverse tan here. So on the right-hand side, you write tan to the power of -1 is equal to 7 on 10. Using brackets there, please. Making sure your calculator is in degrees, and you would get 35 degrees. Is that it? No, it's not, because from the starting point, this was here facing north and then turning around in a circle till you face Walter. So it's not actually just this little bit here in the triangle, it is the 90 degrees to get us facing east. And so that's the writing that we've got here. So Walter's bearing is not just 35, it's 90 plus 35 degrees. You can put the T for true if you want. You may sometimes be asked to do a little bit extra, which might be that, what if we were asked to find the distance that Walter was? Here's Walter here. How far has Walter travelled? So that's the purple line there in the triangle. How could you work that out? It's the hypotenuse of a triangle. Well, you now know this angle in here, which is 35 degrees. To find the side of a right-angled triangle, you could use SOHCAHTOA, trigonometry, using one of the other sides, either one, and the angle. That would help you find the hypotenuse. Or you could use Pythagoras, because you have two sides, the 7 and the 10, in a right-angled triangle, and you could use Pythagoras to help you find the third. Might be something you'd like to try, and that could be a really great question to write in your notes as an example of all the different things that you might have in some of these simple bearing questions. Okay, there are the problems to do now. Thanks for joining me.